Namaste to all of you. Today, in this class, I will explain the concept number of onto functions. Okay, permanent combinations, that to number of onto functions. When we taught functions chapter, we given if the B set, for example, if f is a onto function from A to B, if B set B contains two elements, we given number of onto functions formula. But here, if the set B contains more than two elements, then how you can find the number of onto functions? Okay, and first of all, well, in detail discussion regarding this number of onto functions, first I will tell you what is onto function. If f from A to B is a function, it is a function, is said to be onto function, is said to be onto function if every element in the set capital B has at least one pre-image, okay, this is known as the onto function. Otherwise, simply range is equals to codomain, we can say like this also. Range is equals to codomain. Few examples I will give. For example, if we take this is A, this is B, for 1 2 3 4 like this we may take A B C D E like this. If I given mapping like this, first of all, is this the function or not? It is a function. Function means f from A to B is said to be a function if every element in the set A has unique image. So 1 has unique image A, 2 has unique image B, 3 has unique image B, 4 has unique image B. So it is a function. But for cross checking of onto means a function f from A to B, what is the definition I given, is said to be onto if every element in the set B, that is important, every element in the set B has at least one pre-image. So for A, this is called pre-image. So for A, pre-image exists. B, at least one pre-image means here of course, so 3 exist. But C has no pre-image, D has no pre-image, E has no pre-image. So here F is not onto. Maybe you got one idea regarding this onto now. For example, if you take 1 2 3 4, if you take A B C like this, 1 to A, 2 to B, 3 to B, 4 to C, then we can cross check either this is onto or not. So first of all, function, is the function or not? Function means every element in the set A has unique image. So 1 has unique image A, 2 has unique image B, 3 has unique image B, 4 has unique image C. So it is a function. Okay, function. Then we have to cross check onto. Is it onto or not? Onto means if f from A to B is a function, if every element in the set B, has at least one pre-image in A. So A has one pre-image and B has two pre-images. Let it be, no, not an issue. C has one pre-image. So here F is onto. So onto means here each and every element in the set B has at least one pre-image. If you left one element like this, then this is not onto. Okay, so onto means every element in the codomain has at least one pre-image in the domain. Then only we can say that is onto function. Now, for example, n of A is equals to m, n of B is equals to n. Then here we have to discuss then number of onto functions equals to formula. Here n power m minus nc1 n minus 1 whole power m plus nc2 n minus 2 whole power m minus so on like this. Okay, this is the number of onto functions formula. Okay, before this onto functions already I given. For example, here a b c d, let this is the set A. If here the one set is there, let it be two elements are there. Here total number of functions equals to total number of functions equals to what is the formula? N of b to the power n of a. So here you will get n of b value, two entries are there, 2, n of a 4 elements are there, so 2 power 4. Here this is the total number of functions. Now in all these functions, if all the elements are mapping with 1, this is constant function, this is not onto function. If all elements are mapping with 2, okay, these also function but not onto function. So if the set B contains two elements, in that case number of onto functions is equals to formula 2 power n of a minus 2, where 2 is nothing but n of b. If the set B contains two elements, then within this case the number of onto functions equals to formula 2 power n of a minus 2 is the value. Why this minus 2 came means, here minus 2 means if all the entries are mapping with 1, that is one constant function, or if all the entries are mapping with the second element, that is also a constant function. So due to that reason we are subtracting two functions. Except these two functions, remaining each and every function here existed function is onto. But in all the cases this is not possible now. Whenever n of b means in the set B, if it contains more number of two elements, then in that case this is the formula. If n of a is equals to m, n of b is equals to n, then number of onto functions equals to n power m minus nc1 into n minus 1 whole power m plus nc2 into n minus 2 whole power m. Like that, if you continue this process, here somewhere it will end. That too, here one more important point. In order to exist onto function, for onto function f from a to b, in order to exist onto function, compulsory n of a value should be greater than or equal to n of b. Otherwise n of b, number of elements in the set B, less than or equal to n of a. This is also one more important point. Like this example, if you observe, you can get that idea. So for onto function, the first condition is also nothing but this one only, n of b less than or equal to n of a. And if the n of b contains two elements, in that case 2 power n of a minus 2 is the number of onto functions. If the set B contains more than two elements, then in that case this is the formula we have to apply. Now today in this class I will explain the derivation for the number of onto functions. Of course proof is not important, okay, but subjective point of view how it will be. Okay, here I will discuss number of onto functions, number of onto functions formula, subjective point of view I will derive for you. So here in this set A, let it be some a1 a2 a3, let it be m elements are there. Let this is the set A, let this is the set B. Here I can take some b1 b2 b3 up to so on bn, n elements are there. Now our aim is to find the number of onto functions we have to find. First of all, here total number of functions equals to how many total number of functions here I can form. Total number of functions equal to I can form n power m. Okay, already this is the concept in the functions we given, just one time go through it. Total number of functions formula is n power m, nothing but n of b to the power n of a. This is the total number of functions. Now listen, here I can choose, let capital A1, one event I can take, first element left, first element left without in B, first element left in B. Okay, I am choosing A1 as first element left in B. That means without mapping this element, this is the event A1. A2, A2 means second element left. second element left in capital B. I can take like this. Like that, here an means nth element left in capital B. These are the events I taken like this. A1 means out of all the functions, maybe first element left, second element left is A2, third element is left A3, like nth element is left an. But here onto function means no element left in B. If you left one element, that means left in the sense means for that particular element there is no preimage. Then in that case that is not onto. So here I am taking first element left in B. First element left in B means for the element B1 there is no preimage. A2 means second element left in B. Second element left in B means the element B2 has no preimage. Like that I am choosing this one. Now what I required here, tell me. Now my aim is I have to calculate n of A1 complement and A2 complement intersection, A3 complement intersection, up to so on intersection, an complement. Understand this one? Means A1 complement. What is A1? A1 means first element left. Complement means first element not left and second element not left and third element not left and up to so on till where? Nth element also not left. Why? Because my required functions are onto functions. Onto functions means without left any single element in the set B, each element has preimage in A. Due to that reason, A1 means one first element left in B. But why I am taking A1 complement? Since my requirement is onto functions. For onto functions, nothing element left in the set B. So A1 complement and means first element not left and second element not left and third element not left and up to so on nth element also not left. These are the selections only, that means these are the elements only I required. Then only it will act as the onto function. I hope that this point is clear. Once again, A1 means first element left in B. A2 means second element left in B. Up to so on an means nth element left in B. For example, according to onto function concept, nothing element left. If you left one element, that is not the onto function. Due to that reason, here I am taking the functions as A1 complement. A1 means left. A1 complement means not left. So first element not left and second element not left and third element not left and up to so on nth element also not left. Automatically what is these functions? Nothing but onto functions. Now with the help of the set theory, that too in the set theory, De Morgan laws and principle of inclusion and exclusion concepts are there. With the help of those, I can write n of this whole value. I can write A1 union, A2 union, A3 union, up to so on union, an whole complement. With the help of the De Morgan laws, this value I can write like this. Now which is equals to n of this whole complement means total minus n of A1 union, A2 union up to so on an. Here what is the meaning of total? Total means nothing but total functions from A to B. Here also A1 means first element left in B functions. You may take like that. A2 means second element left in B functions. An means nth element left in B functions. Since we are discussing about the functions now. Now here total means total number of functions. What is the total number of functions from A to B formula? N of B to the power n of A minus. Now again here it is the formula of principle of inclusion and exclusion. So principle of inclusion and exclusion means, what is the formula for this one? Yesterday already we given, in the previous lecture we given sigma n of A1 minus sigma n of A1 intersection A2 plus sigma n of A1 intersection A2 intersection A3 minus so on. This is the formula. Now which is equals to n of B to the power n of A. What is n of B? N elements are there. n of a is equals to m elements are there minus what is this value? Sigma n of a1. What is sigma means? N of a1 plus n of a2 plus n of a3 plus up to so on n of an. First of all, what is n of a1? N of a1 means first element left functions. If you left the first element here, for example, if you left this element, then how many elements are there next again? N minus 1 elements are there. Here m elements are there, here n minus 1. If you leave this element, then remaining n minus 1 elements are there, here m elements are there. Then within that case, total number of functions, how many you will get? N minus 1 whole power m. So n of a1 value is nothing but n minus 1 whole power m plus n of a2. Similarly, n of a2 means sigma is there. So n of a2 means what is that value? B2 element left functions. If I left B2 element, okay, then how many remaining elements are there here? N minus 1. Here how many elements are there? M. Then in this case, by leaving this B2, how many functions I can form? Again same thing, n minus 1 whole power m. Like that here, n of a1 plus n of a2 plus n of a3 plus, how many times you will get? N times. So this value n into n minus 1 whole power m minus. Next, we will cross check. What about this value? Sigma n of a1 intersection a2. What is this meaning? A1 means first element left in B. A2 means second element also left in B. So here if you observe, first element left and the second element left. If you leave these two elements, then how many remaining elements are there? N minus 2. Then how many functions you can form again? N minus 2 whole power m on. By leaving two elements, you can get remaining n minus 2 elements are there, and here m elements are there. In that case, the total number of functions is n minus 2 whole power m. So for b1 b2, n minus 2 whole power m. Like that, b2 b3, b1 b3, b2 b4, b3 b4. Like that, every selection of two events, two sets here. Every selection of two. Every selection of two means out of n elements are there. So nc2, in each selection you are getting n minus 2 whole power m. So here n minus 2 whole power m. Similarly, next value plus 3 selections are there. Out of n elements, here first element left and second element left and third element left. If you leave 3 elements, then remaining n minus 3 are there, whole power m will be there. How you select a1, a2, a3? nc3 into n minus 3 whole power m minus so on. Then simplify this whole value, which is equals to n power m minus nc1 into n minus 1 whole power m plus nc2 into n minus 2 whole power m minus nc3 into n minus 3 whole power m and plus so on. This is the formula for number of onto functions if the set B contains more than 2 elements. Okay, once again listen my class 2 or 3 times, then only you will be perfect. Now one example I will explain here. How they will give example. Find the number of onto functions. Find the number of onto functions from a set A to a set B containing the elements 4 and 3 elements. If they given like this, then how you can find the number of functions, that too onto functions in this case? So here n of A is equals to 4 elements are given and n of B is equals to 3 elements are given. First of all, you can cross check is onto functions possibilities or not. For possibility of onto functions, n of A value should be greater than or equal to n of B. So here it is the possible case is there. Then how you can find number of onto functions equals to number of onto functions is equals to what is the formula? N of B to the power n of A minus next value n of B c1 into n of B minus 1 whole power again n of A and plus 1 means here n power m minus nc1 n minus 1 whole power m plus nc2 n minus 2 whole power m minus so on. So here n is equals to what is the value? 3. M is equals to 4 is the value. Cross check here. 3 power 4 minus 3C1 3 minus 1 whole power 4 plus 3C2 3 minus 2 whole power 4 minus 3C3 3 minus 3 whole power 4. After this term, every value becoming 0. Then calculate this value, you will get the answer. Now, one more example. How they apply this onto functions concept in permutations and combinations. Here listen. 4 different coins or 4 different things. 4 different things. How many ways you can divide? How many ways we can divide into 3 persons such that at least person gets one thing. At least each person gets one thing. This is the bit they will ask. So if you observe here different things are there. Here 3 persons means different. So different things you are assigned to different persons. Whereas yesterday that positive integral devices, non-negative integral devices, here similar we given. For example, for similar things to 3 persons means that is the multinomial theorem concept. Yesterday class we given already. But here it is the case. These are the different items. These are also different. So different. Yesterday previous class is similar to different. So in this case, what is our aim? 4 things are there. Let it be 4 things. How many persons are there here? 1, 2, 3. Okay. How many ways you can assign them? How many ways you can assign them means here indirectly what is the concept? Nothing but onto functions concept. This is the onto functions concept. So directly competitive exam point of view, they never ask number of onto functions. So number of onto functions, that is the concept. Basing on that concept, they will frame the bits like this. 4 different things. How many ways can be divided into 3 persons such that each person get at least one thing. Means at least one thing means without leaving any person. Means compulsory one thing we have to assign. One thing here we have to assign. One thing here we have to assign. So that at least one thing means at least one pre-image should be there. That is the concept. So basing on that question, you have to understand that is nothing but onto functions concept. Immediately you have to apply that onto functions formula. What is onto functions formula? This one. N power m minus nc1 into n minus 1 whole power m plus nc2 into n minus 2 whole power m minus so on. Where n is the number of elements in the set B. Means n of B is equals to n and n of A is equals to m. Then simplify, you will get the answer. Okay. Listen all the videos and prepare the best classroom notebook for yourself only and practice. If you have any doubts, you can send the doubts. I will clarify those doubts, and very soon means maybe tomorrow or day after tomorrow I will plan to start the new chapter probability. Okay, listen the videos and practice yourself. And before that 1 week before I send the assignment also, that permanent combinations total assignment I send you. First you can listen the videos, then try to solve the book assignments, then what I send you assignment you can solve it, then you can go to Singage. Okay, next exam syllabus we will plan the permutations and combinations. Okay, thank you.